Here we're going to discuss algebraic expressions using what's called the commutative and then the associative properties. So first of all, what is 5 plus 2? Good, it's 7. But what is 2 plus 5? It's still 7. Does it matter which number comes first? No. Same. What is 9 times 2? 18. But what is 2 times 9? It's still 18, because doesn't matter which numbers come first, the answer is no, and this is what's called the commutative property. The commutative property states that the order of the numbers can be changed without affecting the sum, that was the first example where we were adding, or the product, that was when we were multiplying. If a and b are real numbers, this means a plus b is equal to b plus a, and a times b is equal to or equivalent to b times a. But notice, this is just for the sum or product. Does the commutative property hold true for division or subtraction? And if so, give an example, and if not, give a counterexample. Okay. 3 minus 6 versus 6 minus 3. 3 minus 6 is negative 3. 6 minus 3 is positive 3. So these two would not equal each other. 10 divided by 2. 2 divided by 10. 10 divided by 2 is equivalent to 5. 2 divided by 10 is equivalent to 1/5. And these are not equal. So does it hold true for division or subtraction? The answer is no. And here's an example of each case. Yay! Okay. Next up, we're going to practice and do some more. Okay, let's look at some other operations and how they affect numbers. Okay, consider 2 plus 4 plus 6. What happens if you put parentheses around any two adjacent numbers? How does it change the sum? If I had 2 plus 4 plus 6, for example, or 2 plus 4 plus 6. With order of operations, 2 plus 4 is 6, and then 6 plus 6 is 12. Over here, 4 plus 6 is 10, and 2 plus 10 is still 12. It does not change the sum. Well, let's consider 3 times 6 times 4 then. What happens if you put parentheses around any two adjacent numbers? How does it change the product? Meaning 3 times 6 times 4, or 3 times 6 times 4. Okay, 3 times 6 is 18. 18 times 4, 72. 6 times 4 is 24. 3 times 24 is also 72. It does not change the product. And this is called the associative property. So the associative property, the order of the numbers does not change. However, the grouping of numbers can change and does not affect, once again, the sum or the product. Which means if A, B, and C are real numbers, then A plus B plus C is equivalent to A plus B plus C. Notice I changed the parentheses around. Also, A times B times C is equivalent to A times B times C, as you can see. Now, once again, does the commutative property, or excuse me, this time it's the associative property. Does the associative property, the last page was commutative, this one's associative. Does it hold true for division or subtraction? If not, give a counterexample. Okay, so let's try 10 minus 5 minus 4, 10 minus 5 minus 4. Let's put parentheses around the last two numbers here and the parentheses around the first two numbers and see what happens. 5 minus 4 is 1. 10 minus 1 is 9, so remember 9. 10 minus 5 is 5, and 5 minus 4 is 1, which is not, no. And let's look at division. So let's look at 20 divided by 4 divided by 2. 20 divided by 4 divided by 2. Once again, let's put parentheses, so let's see. Okay, 4 divided by 2 is 2. 20 divided by 2 is 10, so remember 10. 20 divided by 4 is 5. 5 divided by 2 is not 10. So the answer is no. The associative property does not hold true for division or subtraction, okay? So now, let's practice on the next page. All we want to do is name the property or properties used to write the equivalent expression. So basically, I'm looking to see if anything got moved around, which would tell me the commutative, or if the parentheses got moved around, which would be the associative. So here we go. 5, negative 3, 2. 5, negative 3, 2. So the order of the numbers is the same, which tells me it's not going to be the commutative. So let's look at the grouping, the parentheses here. I notice, okay, this is going to be the associative property of addition. The next one. 8 times 4 times 6 equals 6 times 8 times 4. Oh, notice the order. It's not in the same order. So I'm looking at the commutative property. 8 times 4 and then times 6 just got switched around. The grouping of the parentheses is still the same. So this would just be the commutative property of multiplication. When you talk a lot, you sometimes start to cough too. So try and get that under control. How about this next one? What do you see for C? P, U, T, T, U, P. Well, it looks like I have the commutative property of addition because we switched the order. It looks like we actually switched it twice because U plus T is still in the parentheses. So this is twice, but it's still just one property, the commutative property of addition. Which brings us to a very nice little box on this page. You might notice it's a with properties. Look closely at each piece of the problem. The changes may be very subtle, and it was. Notice I was looking at the order of each of the terms. I was looking to see what was moved around, if the parentheses moved around, and you really have to take your time, which means I really want you to take your time and give this page a try. Pause the video, see what you can do. So, what did you do? You went ahead and identified the property or properties used to find the equivalent expression. So here we go. 11 plus 4 plus 5 equals 5 plus 11 plus 4. The order changed, so we know there's the commutative property of addition, but also the grouping of the parentheses. Here I have 11 plus 4. Here I have 5 plus 11. So it's the commutative and associative properties of addition. Awesome. Next up, v times y times b, v times y times b. The order of the variables did not change, so I'm not thinking of the commutative property. But I noticed the parentheses were regrouped, so it would just be the associative property of multiplication. and write out everything. You remember better. Write out everything. The whole word associative property of multiplication. 8 plus 1 plus 6. 8 plus 1 plus 6. The order of the numbers did not change, but the parentheses got regrouped. So this is the associative property again of addition. Let's do another. 9 times 13 times 14. 13 times 9 times 14. Subtle. Just 9 times 13 was moved around. The order was switched. Parentheses stayed the same. This would just be the commutative property of multiplication between these two numbers. So this is the commutative property of multiplication. So now the question is, did you try number 3? Did you? Let's do it. The following proof shows 3x times 2y is equivalent to 6xy. So it's going to show this, okay? We're going to fill in each blank with either commutative property or associative property to indicate the property being used. And we're also going to say, is it of multiplication or of addition? So let's do all that, okay? 3x times 2y is equivalent to 3 times x times 2 times y. Well, notice the order stayed the same, but we regrouped the parentheses. This would be the associative property let's go ahead and fill it all in, of multiplication. Next up, it looks like it just went from x times 2 to 2 times x. I just switched the terms around, so that means that I switched the order. It's the commutative property of multiplication. And then 3 times 2, 3 times 2, x times y, x times y. So the order didn't change, but the parentheses did. One more time, associative property of multiplication. And then 3 times 2 is 6, x times y is x times y, so this shows you that 3x times 2y is equivalent to 6xy, which is getting us ready to one question to beat the test. Fordson High School hosted a math competition. A student completed the following proof and the question was marked incorrect. Identify and correct the student's mistakes. Okay, so let's see what happens here. 2x minus 5 plus 3x equals negative 5 plus 2x plus 3x. Well, all we do is switch positive 2x and negative 5. We switch the order, which tells me that's the commutative property of addition. So that is correct. Next up, just copy this down. And now, negative 5 plus 2x plus 3x equals negative 5 plus 2x plus 3x. Looks like we regroup the parentheses, and that's fine. In that case, that'd be the associative property of addition. Okay, so we're good so far. Okay, so what do we have now? Copy that down, we're good. Okay, now this is equivalent to negative 5 plus x times 2 plus 3, because of course we had a common x with these two terms, and we use the distributive property. Okay, so far this is great. Let's see what happens next. Negative 5 plus x times 2 plus 3, okay, we're still good there, equals x times 2 plus 3 minus 5. Okay, that's fine. Just switch them. It's like adding negative 5. That'd be the commutative finally. So identify. I have identified. That one should be the commutative property of addition. Okay, let's keep on going. Then lastly, x times 2 plus 3. 2 plus 3 is just 5. So just wrote an equivalent expression. That's fine right there. So it looks like the only issue was just that one word, but one word, like with anything, can make a difference. Associative versus commutative. And again, I remember commutative, personally, I think of the commutative like a commuter bus. When you commute, you move around, so the order moves around. When you associate's like grouping things. So the associative property is like regrouping. That's how I remember it, and hopefully that might help you remember it. And that means we're done with this video, so I'll see you, as usual, in the next video.